Hello friends, today we'll discuss the next topic in the subject Basic Electrical and Electronics Engineering. The topic is Thevenins Theorem. Basically, Thevenins Theorem is used where the one component of any complex circuit is keep on changing. Hence, if you solve the problem with the help of KVL, KCL or other kind of theorem, then you have to solve a number of loops or nodes to find the current in that particular branch which keep on changing. This theorem provides an easy method for solving such kind of complex circuits. Uh, According to Thevenin's theorem, it states that any two-terminal linear active and bilateral network can be represented in a simplified equivalent circuit known as a Thevenin's equivalent circuit. For example, we have a circuit that is given in figure number 1. Here branch AB has a tendency to keep on changing. Currently the value of resistance that is connected in the branch AB is 12 ohm, but it can change from 12 ohm to any value. For that case we have to apply the KVL for two different loops and solve the two currents and find the current in AB branch. But while uh, using Thevenin's theorem, we have to just convert this particular complex circuit into a practical voltage source. VTH is a Thevenin's equivalent voltage or open circuit voltage, and that is a series resistance. As you know that this resistance can be considered as the internal resistance of the voltage source for a practical voltage source. As we know that for ideal voltage source, this resistance value is 0. But as we are applying the Thevenin's theorem, hence it will have a some value that is known as Thevenin's equivalent resistance. And finally, we can find the value of current or voltage or anything in the branch AB that is of 12 ohm resistance. Here RL is a 12 ohm. We have already find the VTH and RL. Then we can find the value of load current or current in the branch AB. Let us consider how we'll find these parameters, means Thevenin's equivalent voltage and Thevenin's equivalent resistance for the Thevenin's equivalent circuit. Firstly, we'll consider how we'll calculate the value of RTH. The first step, we will open the terminal across which we have to find out the Thevenin's equivalent. As we have to find the current in branch AB that has a value of 12 ohm resistance, so we have to just open it. So it will look like this one. The second step is to find out the RTH. We will replace the all sources by, only independent by the equivalent internal resistance. Means ideal voltage source will have a short circuit because it has zero resistance, and ideal current source will have a open circuit and because it has a infinite resistance. Hence our circuit will be like this one. This 6 volt voltage source will become shorted, and 12 voltage source also becomes shorted, and the circuit will look like this one. Now we'll consider a current I is entering from a terminal A and leaving from terminal B. As it reaches as point A, it will have two paths. It can go via 2 ohm resistance, and some part will go via 1 ohm and 3 ohm path. The current will divide into two parts, means I1 and I2. As we know that if the current is same, then the two elements will be in series, and if the current is different, then two elements will be in parallel. Here you can see 1 ohm and 3 ohm will carry the same current, that is I2, and the 2 ohm will carry the current I1. Here 1 ohm and 3 ohm will be in series, and this part I1 and this part I2, because they are carrying different currents, they will in parallel. So accordingly we can say that 1 and 3 are in series, so equivalent will be 4 ohm. uh, and this 4 ohm and 2 ohm are in having the different current, hence they will be in parallel. In figure this particular one, the 2 ohm and 4 ohm resistance currents is different, hence they are in parallel, and we can find the value like this way. If two resistors are in parallel, then R1 into R2 upon R1 plus R2, the value will be 1.33 ohm. So hence, for the equivalent circuit, the Thevenin's equivalent resistance can be calculated as a 1.33 ohm. Now we have to go for the calculation of the Thevenin's equivalent voltage. So we will do the same thing. We will open the terminal across which we have to find out the Thevenin's equivalent. uh, then we will find the voltage across the terminal which is open. This is known as a VTH, or Thevenin's equivalent voltage, or open circuit voltage. So circuit will be same as we have discussed in the previous. So, the AB will be open circuited, and we have to find the voltage of AB. So it can have a two kind of methods, like we have to apply the KVL, because a single loop, and the KVL will be like this one, 12, because we have considered the current will flow this one. So this is a positive, and current is leaving from there, hence it will be positive. And these are resistances. There will be voltage drop, minus 2 plus 1 plus 3, 2 1 3. Into current will be same, that is I. And because current is entering in the positive terminal of a voltage source, hence it will be negative. uh, Please remember, if the current is leaving from the positive terminal, then source will be taken as positive, and current is entering from the positive terminal, then current will be then the source will be considered as a negative. So from 12 volt, because current is leaving from positive terminal, this is positive. For the 6 voltage, the current is entering in the positive terminal, hence it will be taken as a negative. So that's why this equation will be here. You can, after solving, the value of current is 1 ampere. uh, Now if you have to find the voltage of AB, then we can break this AB like this, A to C, C to D, and D to B. So if we have to find the voltage of terminal across AB, so we can write VS, voltage of VAC, voltage of VCD, voltage of VDB. So voltage of VAC will be have a 2 ohm of the resistance. Current is as the current is going this way, the current arrow is positive, this one, and the voltage is here, because current in the resistor, it is a passive element, and energy will be dissipated. The direction of the voltage and current will be different here. If the current is going this way, the positive terminal will be here. So the value of current is 1 ohm, sorry, 1 ampere. Hence the voltage will be plus of 2, because a terminal is positive, plus of 2 into 1 ampere. And CD, because C terminal is positive, plus of 6, and in dB there is no element, the voltage of dB will be 0. So after putting these values, the VAB or VTH will be have of the 8 volt, because we can solve like this way. So VTH will be 8 volt. Like either we can go in this way, this method also we can find the same way, you can practice the same way. Here 2 into 1, 2 volt, plus 6, it is a 8 volt, so VTH will be 8 volt. Now we have to just use the same circuit of, that is a Thevenin's equivalent VTH series RTH, and the load that we are removing from the circuit, that is AB. We are just putting that the same load resistance in the branch AB, that is of 12 ohm. So that is a complete Thevenin's equivalent circuit. As we have calculated, the value of VTH is 8 volt, and RTH is a 1.33 ohm. Hence, putting these values in the given circuit, here RL is of 12 ohm. The value of load current will be 0.6 ampere. So this is a method by which we can find the current in that particular branch. The advantage of using this method is, if the value of RL is say it changes from 12 ohm to 6 ohm, we have to just put the value of RL here 6, because we have already VTH and RTH. So we do not calculate the value of different currents and all the things. If we have a Thevenin's equivalent circuit, we can find the current, voltage, all these things in the branch AB, which have a tendency to keep on changing. So, thank you for listening. We will discuss the next topic in the next presentation.